Let's talk about how to write ionic compound formulas. Some books refer to it as inorganic compound formulas. First thing I'm going to tell you is if you don't know how to name the compound from a formula, you should look at my 3 videos, part 1, part 2, part 3, on that first. If you know how to write the names from the formulas, I think it's going to make writing the formulas from the names a lot easier. To me, that's the harder of the two to do. So let's take a look. All right, so what I have here are 4 compound formulas written. And take a minute, pause the video, and try to write the formula. And then check out the answers. All right, so let's take a look. Now, before you do anything, just like I say on the videos for writing compound names from the formulas, there's some bits of information you need to know. If you look at this periodic table, what I'm doing in blue here is boxing metals that you should know the charge for. So your group 1s are always +1. That's the left-hand column. Right next to them, the group 2s +2. Then aluminum is +3. Zinc and cadmium are +2s, and silver +1. Okay, the rest of the metals here in the middle, those are what we call transition metals or transition elements. Sometimes they have one charge, sometimes they have another, and that is going to depend on what it's bonding with and what the name looks like. So we'll get to that in a moment. The other thing that you need to recognize is, again, another bit of information to have in your brain, is you must memorize polyatomic ions. Now, you might have a teacher or professor that gives you a table of polyatomic ions, and you can refer to that, just like your teacher might give you a periodic table that gives you charges for the elements. But basic ones, I'm going to suggest you memorize them anyway, because then you're going to see how to solve the question, right? Answer the question, or see how to write the formula or the name from the formula very quickly. And it's less frustration. So a little bit of information that you can have in your brain is going to do a world of difference. So that is for the metals, knowing which ones are only going to give up the same number of electrons so they have the same charge, and knowing some of the polyatomics. So here's a list of some of the common ones. I'm not saying this is all of them. There's a lot more. But if you know the formulas and the charges for these, and you recognize the names, it totally makes your life easier. All right, so let's go back. Okay, sodium sulfite. Well, sodium is Na. It has a +1 charge because it's a group 1 metal. Sulfite. Anytime you see the ITE or ATE ending, you have a polyatomic ion. Now, sulfite happens to be SO3. It's a cluster of atoms with a -2 or 2- charge. So what does this mean? Sodium, every atom of sodium wants to give up 1 electron. Every cluster of atoms of sulfite want 2. They don't balance out. So you have to have 2 sodiums then for every 1 sulfite. What your teacher might be mentioning, or a book or another video, is you can just take the numbers and crisscross the numbers. In other words, I need 2 sodiums for every 1 sulfite so that my electrons lost and my electrons gain balance, and that is true. So the way we would write sodium sulfite would be Na2SO3. That's the correct formula. Let's go to the next one. Now, cobalt, Roman numeral 2 chloride. The Roman numeral is an indication of the charge for the metal. Cobalt is right here. It's in transition metal land. So it has more than one way it can give up electrons. In this case, you're dealing with cobalt giving up 2. So I have CO +2. Chloride, the IDE ending means I have an element. It's chlorine, right? We changed the ending to IDE. It's right next to the noble gases. Anytime I have a nonmetal on the right-hand side of the periodic table bonding with a metal. The metals are the givers and the nonmetals are the takers. So this group, group 17, would all gain an electron. They have 7 valence electrons, they need one more. In other words, for chloride or chlorine, -1. The charges don't cancel, just like they didn't cancel in sodium sulfite. So all I'm going to do is I need then 2 chlorines, each taking an electron for the 1 cobalt. In other words, I'm going to crisscross just the numbers to balance out my electrons. So it's going to be CO, Cl2. Ammonium nitrate. Let's take a look at that. You need to be able to recognize that ammonium is a polyatomic ion. And for that matter, nitrate is as well. So, the ammonium ion, NH4, with a plus or +1 charge, nitrate, NO3, with a minus or -1 charge. Since it's 1 to 1, you already have your formula. Just rewrite it without the charges, so it's NH4, NO3. And finally, for aluminum hydroxide. Aluminum is a metal that only gives up the same number of electrons, which is +3. Hydroxide. Now, hydroxide, cyanide, they're examples of polys with an IDE ending. So sometimes if students don't memorize some of the polys, including hydroxide, they think it's just one nonmetal. But it's not. Hydroxide is OH minus. So, you can't be creative. You can't make up your own rules. You need to memorize some of the polys. So if we go back, I have aluminum with +3. I have hydroxide with a minus or a -1. So aluminum wants to give up 3. The hydroxide poly wants to gain 1. In other words, I need 3 hydroxides for every 1 aluminum. Now, for this, let me just show you this. Let me just erase some of this. I'm going to go ahead and I'm going to crisscross those charges to balance out my aluminum and my hydroxide. So as I mentioned, I have, now I'm erasing it. I have 3 and I have a 1. Be careful. Rookie mistake. Some students will write, oh, it's got to be AlOH3. But that is not correct. It's 3 hydroxides, not just 3 hydrogens. Anytime I have a polyatomic and I'm writing it in a formula and it's appearing more than once, do not forget the parentheses. So Al parentheses OH close parentheses 3 is aluminum hydroxide. So you got to memorize a little bit. It's going to go a long way. Remember that your polyatomics, they're easy to spot when there's the ATE and the ITE ending. There are a few exceptions. Hydroxide is one, cyanide is another. If you're allowed to use tables, have them in front of you. Don't practice any of this without that. And if you don't get very much to go on, you better memorize some stuff. And line them up, put the charges above. If they don't cancel, then you're going to go ahead and balance out electrons lost and electrons gained by switching the numbers. And also remember, again, your polyatomics, you need the parentheses. Keep working hard, and good luck.